Hello everyone, welcome to the channel again. My name is Sujal Thakur and today I'll be telling you about the support vector machine SVM algorithm in machine learning. The support vector machine or SVM is a supervised learning algorithm. Supervised learning, as I have already said in many of my previous videos, means the data already has inputs and correct outputs. SVM is mainly used for classification, but it can also be used for regression. Most commonly, it is used for yes/no type problems. What SVM does? SVM tries to separate data into different groups by drawing a line. This separation is called a hyperplane. The figure that you are seeing in front of your screen, the straight line is called the hyperplane, which divides data in its either side. It draws the best possible line, such that distance between the line and the nearest points from both sides is maximum. This distance is called the margin. The closest points to the line are called the support vectors, or to be precise, the support vector machine. Okay, let's scroll down. At first, we import the libraries that we'll be needing for this. First, we import the support vector classifier from sklearn to create the SVM model. We further import the datasets that we'll be using here. Matplot to plot graphs and visualize the results. This libraries helps us build, train, and visualize the SVM model easily. Step 2 will be loading the dataset. We use the breast cancer dataset provided by sklearn here, where X is the input features, is basically the patient data. Y is the output labels, cancer or no cancer. The dataset has many features, but for visualization, we select only two features, so we can plot them on a 2D graph. Step 3 is creating the SVM model. We create an SVM classifier using SVC. We do kernel equals linear, means SVM will draw a straight line. This works well when data can be separated using a straight line. The next step will be training the model. We train the model using SVM fit XY. It finds the best separating line and keeps the maximum distance from closest points. Is that the support vectors? Now we'll visualize the decision boundary that we have created just now. Now to understand how this works, we draw the decision boundary. We also import, or to be precise, we also give here background colors to show which area belongs to which class. The line in between is called the hyperplane. Scatter points here shows the actual data right in front of your screen. Now this helps us visualize and confirm how well SVM separates the classes. Now the last step is to predict. Now once trained, SVM can predict the class of new or unseen data. It decides which side of the line the point lies in. Now to summarize this in one sentence, SVM is easy to use. You load data, you create model, you train it, and you visualize and predict. The last line is something on the funnier side, where SVM is the middle line, radicals on one side, liberals on the other. Thank you.